Hello children, welcome to this mathematics class. ఈ పాటికి మన స్కూల్ స్టార్ట్ అయ్యి మనం చక్కగా క్లాసెస్లో రన్ అవుతూ ఉండాలి, కానీ యు నో ద సిచ్యువేషన్ అండ్ వీఆర్ నాట్ ఏబుల్ టు స్టార్ట్ అవర్ క్లాసెస్. ఎనీవే, వీఆర్ సీకింగ్ ఫర్ ద ఆల్టర్నేటివ్ వేస్ ఆఫ్ టీచింగ్. సో వన్ ఆఫ్ దెమ్ ఈస్ దిస్ కైండ్ ఆఫ్ టీచింగ్. సో whatever way we teach, you need to learn as you are learning in your real classes. Okay, ready? So 9th class mathematics classes ki swagatam. మరి ఈరోజు మనం ఒక మంచి చాప్టర్తో స్టార్ట్ చేసుకుందాం. లెట్స్ స్టార్ట్ విత్ చాప్టర్ నెంబర్ 4, దట్ ఈస్ లైన్స్ అండ్ యాంగిల్స్. Let's start with the basic terms of geometry. Let us start recollecting the basic terms of geometry that we have learnt in our previous classes. Okay, point, point, we learnt about point, line, we learnt about line. Okay, can you remember AB, line AB, and we denoted like this AB, and line segment. All these things we have learnt in our previous classes. Line segment, in fact ray. What is a ray? A ray starts with a point and goes on endlessly. Ray, all these things we have learnt in our previous classes. So what is the basic difference between line and line segment? Yes, a line has no end points. It has neither beginning nor ending, whereas a line segment has a beginning as well as ending. It has end points, both end points. That's why it has a definite length, or we can measure it, whereas we cannot measure the length of the line. So that's the basic difference. Line segment is a part of line. Like that, we have learnt so many things in our previous classes. All these point, ray, line segment, and all these things we have learnt in our previous classes. Right, see this. Here we find a line and there are 3 points on it, P, Q, R. The question is, how many line segments are there on this line? This is the question. Okay, right, forget about this, first focus on this. So observe this line, there are 3 points P, Q, R on it, and my question is how many line segments are there? Yes, you can see there is a line segment PR and PQ and QR. So we can find 3 line segments here. Do you notice that? Are there any other line segments in here? These are the only three line segments on this particular line. In the same way, if we see, here is another line and there are 4 points on it. Now count how many line segments are there. So here, since we have 4 points, how many line segments can we obtain or extract from this? See, let me write like this. First PQ, let's start with PQ, PR, PS. So I start with P and I found 3 line segments, and let me start with SR, SQ, and let me start with R, and I can observe that RQ is the line segment. So how many are there? 1, 2, 3, 4, 5, 6. Total 6 line segments obtained. Here how many line segments obtained? 3 line segments obtained. So if I give 5 points on it, how many line segments can be obtained? Yes, we need to find a logic here. See, since I have 3 points on this, I obtain 3 into 2, that equal to 6, and half of it I can obtain. So 3 line segments. In the same way, here I have 1, 2, 3, 4 points. So 4 into 3, that equal to 12, and half of it, 6 line segments I obtain. So likewise, if I have 5 points on the line, number of line segments that can be obtained equal to 5, and that's its following number, its preceding number is 4. 5 into 4, that is 20, and make it half, that is 10 line segments you are going to obtain. So likewise, we can find number of line segments, those can be obtained in this kind of situation. Okay. So if we have 2 points on a line, we can get 1 line segment, and 3 points we can obtain 3 line segments. And suppose if we have 4 points, as we seen, we can get 6 line segments. And what about if we have 5 points? We can get 10 line segments, and 6 points 6 into 5, 30, half of it 15 line segments we can derive from it, and suppose if I have 7 points we can get 21 out of it. Likewise we can find logic, right? You can fill the table which was given in the textbook. Right, now let us talk about angle. Let's try to recollect about angle. So what is an angle? See here, when two rays are originated from a same point, the angle will be formed, right? So or you can say like this, when a ray is rotated from its initial position to another position, one position to another position, when a ray is rotated from one position to another position, angle will be formed. So this is initial position, that means starting position, and this is ending position or terminating position. So likewise, when two rays are started from a same point, the angle will be formed. This is known as common vertex for the both rays, common vertex. And these are the arms of the angle. All these things we have learnt, arms of the angle. So angle, yes, in what units do we measure angle? In degrees. So yes, what are the types of angles? What are the types of angles? Yes, first 0 degrees, that means 0 angle. When there is no when initial ray and terminal ray are in the same position, when there is no angle, that is measured in 0 degrees, that means that is 0 angle. So between 0 degrees and 90 degrees, what name was given to it? Very good, acute angle. Then what about 90 degrees? What is the name of the 90 degrees? Right angle. Okay, right angle. And what about the angles between 90 and 180? Between 90 degrees and 180 degrees, it is known as obtuse angle. Can you remember all this? Can you recollect all these names of the angles? And what about 180 degrees? Exactly, it is a straight angle because it looks like a straight line, and also it is known as linear angle. So from there, from 180, between 180 and 360, what is the name given to it? Reflex angle. And what about 360 degrees? Indeed, it is complete angle. So likewise, we have various names for the various measurements of the angles. So among those, 0 angle, right angle, straight angle, complete angle are the names to the specific angles for some ranges from between 0 and 90 it is acute angle, and between 90 and 180 it is obtuse angle, and between 180 to 360 reflex angle. Likewise, remember all those things, names of the angles. Okay. Now let us see some of the types of the lines here. Observe here is a line PQ and here is a line RS. Do you find any common point for both these lines? Obviously no, there is no common point to these two lines. If you see this case, you can understand better. See here is a line PQ and here is a line RS, two lines are there. So they do have a common point O. That means this O lies both on PQ as well as on RS. That's why O is common to both PQ and RS. Unlike that, here these two lines do not have any common points. So here these two situations made me to define two types of lines. Here non-intersecting lines, that means the lines that do not meet, non-intersecting lines and intersecting lines. Non-intersecting lines and intersecting lines, these are the two types of the lines. So these non-intersecting lines, also popularly known as parallel lines. So what are parallel lines? What are parallel lines? Lines that do not have any common point, or lines that never intersect, or the lines that never meet are called parallel lines. And whereas the lines that have a common point are known as intersecting lines. So observe here, these are the intersecting lines and these are the non-intersecting lines or parallel lines. So likewise, we have seen some examples for parallel lines in our earlier classes and examples for intersecting lines as well. So these are the types of the lines. Let me show you one more type and move further. Now let me show you one more type of angles. See here, many lines are passing through a same point or meeting at a same point. So here only two lines have a common point. Here many lines have a common point. What I mean is, through a single point so many lines are passing. This kind of lines are known as concurrent lines. Concurrent lines. What are concurrent lines? What are concurrent lines? If more than two lines have a common point, those lines are known as concurrent lines. This particular point where all lines are passing, this particular point is known as point of concurrence. So we have three kinds of lines. One is intersecting lines, non-intersecting lines, otherwise parallel lines, and third one is concurrent lines. Okay, these three are also very important for us to learn. Right children, until now we have discussed about various basic points of lines and angles. Now let us quickly jump to the exercise 4.1. I want to leave you the first two questions I want to leave for you. So 1 and 2 do on your own, and let me start with third one. In third one we have 8 statements which needs to be verified whether true or false. Okay, let me do one by one quickly. Follow carefully. So now see, first one, a ray has no end point. Is it true or false? Think a second. A ray has no end point. Obviously it is a false statement, because a ray has a beginning. That means one end point is there. Since it has a beginning, of course it goes endlessly. So since it has an end point, we must say a ray has an end point. So that's why it is a false statement. A ray has no end point, it's a false statement. Okay, right, it is false. And now see the second one. Line AB is same as line BA. Indeed, no problem. You can change the order of the lines. You can call it as line AB or line BA, whatever it, no problem. So it is a true statement. Okay, right. And in the same way, third question given, ray AB is same as ray BA. Here you can see the violation. Ray AB is certainly different from ray BA, no doubt, because it indicates, ray AB indicates means starts A and goes towards B, So whereas ray BA indicates that it starts at B and goes towards A. That's why these two are clearly different. That's why ray AB is same as ray BA. It is a false statement. Okay, let me go for the fourth one. What is fourth one? A line has a definite length. A line has a definite length. Here observe the word line. We cannot define it. It has no end points. How can we measure a thing that have no end points? If they have end points, if both beginning as well as ending, we can measure it. That's why, since a line has no end points, we cannot measure it. That means a line has a definite length means it's a wrong statement. In fact, had it been given like this, a line segment has a definite length, then the statement would have been true. So that's why a line has a definite length is a false statement. Okay, now let me go for fifth one. A plane has a length and breadth but no thickness. Plane, this is a new term, plane. Don't worry, I'll explain in the later sessions. But here, what is a plane? This is a kind of plane like this. Okay, in this board is like a plane, but here it has a length, as well as breadth, but no thickness. Such things are known as, such geometrical things are known as planes. So, a plane has length, okay, correct, breadth, okay, correct, but it has no thickness. That is a true statement. Right. Now, let me quickly move to sixth one. Two distinct points always determine a unique line. Indeed, it is also a true statement. Why? Suppose if you take two distinct points, two different points, how many lines can you draw connecting those? Clearly, you can draw only one line, a unique line. You cannot draw more than one line. That is why two distinct points means different points always determine only one line, that is unique line. This is a true statement, right? So, and let me go to seventh one. Two lines may intersect in 2 points. Read the statement carefully. Two lines may intersect in 2 points. Suppose if I take one line like this and one more line like this, in how many points they can intersect? If they at all intersect in only 1 point, there is no question of intersecting other point. So, one line is going like this, one line is going like this. They can meet only 1 point and no more meetings. That is why two lines may intersect in 2 points. It is not possible. If at all they intersect only at 1 point. That is why it is also a false statement. And let me quickly jump to the last one. Two intersecting lines cannot both be parallel to the same line. In fact, it is true. Here, see, here are the two lines. Suppose this particular line is parallel to another line, like this, parallel to another line. So, this cannot be parallel to this other line. That is what it is telling. Two intersecting lines. Suppose lines are like this. Two intersecting lines cannot both be parallel to the same line. Suppose this line has a parallel line like this. So, it is parallel to this line only. This cannot be parallel to this one. That is what? Two intersecting lines cannot be both parallel to the same line. That means it is a true statement. Likewise, we have verified all the validity of all the statements, and you understood well, I think. So, one more question is there, following question is there. That is also a very easy one. Do it and finish the exercise 4.1, and I will send you the questions list if possible. So, do it and learn quickly. Okay, right.